A telescope built to map the invisible just found an entire galaxy that barely exists, and it contains 1,000 times more dark matter than visible stars. That is not a theoretical prediction. That is measured data from the European Space Agency's Euclid Space Telescope, and it is forcing scientists to rethink what a galaxy actually is. Euclid launched on July 1, 2023, from Cape Canaveral aboard a SpaceX Falcon 9 rocket. Its mission is unlike any telescope ever built. It was not designed to take beautiful photographs of nebulae or hunt for exoplanets. Euclid was built for one single purpose: to map the distribution and influence of dark matter and dark energy across 10 billion years of cosmic history by surveying more than 1/3 of the entire sky. In its early release observations published in 2024, Euclid turned its instruments toward the Perseus galaxy cluster, one of the most massive galaxy clusters in the nearby universe, roughly 240 million light-years from Earth. Inside that cluster, Euclid detected something previous telescopes had completely missed. Hundreds of ultra-diffuse galaxies, galaxies so faint, so spread out, and so lacking in visible stars that they are nearly invisible against the background of space. Among these was a class of object that challenges the very definition of a galaxy. These ultra-diffuse galaxies contain so few stars that their total visible light output is barely measurable. And yet gravitational lensing analysis, the bending of light from more distant objects behind them, reveals they are sitting inside enormous halos of dark matter. In the most extreme cases, these galaxies appear to be more than 99% dark matter by mass. They are galaxies made almost entirely of something we cannot see, cannot touch, and cannot directly detect with any instrument ever built. This is not the first time dark matter-dominated galaxies have been found. In 2016, astronomers using the Dragonfly telephoto array discovered Dragonfly 44, a galaxy in the Coma cluster that appears to be approximately 99.99% dark matter. It has roughly the same total mass as the Milky Way, but produces less than 1% of the Milky Way's light. It is a ghost galaxy, massive but nearly invisible. What makes Euclid's findings different is scale. Previous discoveries found individual dark matter-dominated galaxies one at a time, using painstaking targeted observations. Euclid is finding them by the hundreds in a single survey field. That changes the scientific question entirely. These are not rare anomalies. They may be common, potentially more common than the bright visible galaxies we have been studying for centuries. And that raises a deeply uncomfortable possibility. If the universe contains large populations of galaxies that are almost entirely dark matter, then the total amount of dark matter in the universe could be distributed differently than our current models assume. The Lambda-CDM standard model of cosmology, the framework that explains how the universe formed, evolved, and expanded, makes specific predictions about how dark matter should clump and where galaxies should form. Ultra-diffuse galaxies, with extreme dark matter fractions, challenge those predictions because they represent structures that formed and survived in ways the simulations struggle to reproduce consistently. There is also the opposite mystery. In 2018 and 2019, astronomers found two galaxies, NGC 1052 DF2 and NGC 1052 DF4, that appeared to contain almost no dark matter at all. If dark matter is essential for galaxy formation, how do you get galaxies without it? And if dark matter is not essential, how do you get galaxies made almost entirely of it? Euclid's full 6-year survey will map approximately 1.5 billion galaxies. The dark matter map it produces will be the most detailed ever created. Scientists expect it to reveal whether dark matter-dominated galaxies are genuinely common across the universe or concentrated in specific environments like dense galaxy clusters. Follow for more on the discoveries reshaping what we know about the universe. And tell me, if most of the galaxies in the universe turn out to be invisible, made almost entirely of something we can't detect, does that change how you think about what's out there in the dark?